Now today we'll see practical example on K-nearest neighbor. Suppose we have a data set of fruits with two features, sweetness on x-axis and weight of the fruit on y-axis. Each fruit belongs to one of three categories. Here we have a training data set, apple, orange and banana. So the training data set comprises of three different category of fruits, apple, orange and banana. 10 samples of apple and 12 samples of orange and 12 samples of banana. Similar fruit tend to have a similar features. KNN uses this principle to classify a new data point. Because here we are having two data sets, training data set and testing data set. So these points, whatever the visible on the screen, are the training data sets. And suppose an unknown fruit was detected. A new fruit with sweetness 65 and weight with 60 grams needs to be classified. Notice how this point is positioned between all three fruit groups, making this a genuine classification challenge. Suppose here we are having one new fruit with 65 and 60 coordinates. Now we have to identify whether this new fruit is belongs to apple category or orange category or banana category. Here we have taken sweetness of the fruit on x-axis and weight of the fruit on y-axis. So there is a test point, an unknown fruit, a test point with 65 and 60, and we have to identify whether this fruit is belongs to which group, whether the fruit is belongs to apple category or the fruit is belongs to orange category or the fruit is belongs to banana category. The classification question, looking at the diagram, we can see three distinct clusters of fruits. The unknown point lies in the middle region. Is it closer to the apple category or the unknown fruit? Is it closer to the orange category or the unknown fruit? Is it closer to the banana category? We have to identify. So that's the reason why K-nearest neighbor classifier will use distance measure. In fact, we have a variety of distances, like for shortest distance measurement we'll have Euclidean distance, and for longest distance measurement we have Manhattan distance, and the maximum of two coordinates and picking a maximum value. We are having one more distance, Chebyshev distance. So likewise we are having so many distances to measure the distance from training data set to training data point to testing data point. So now here we are trying to use Euclidean distance from training data points to testing data point. So KNN approach. Now let us consider we have to identify k is equal to 3. That means we are trying to identify 3 fruits which are nearer to testing data point. Even k equal to 5 also. So in that case we have to identify 5 fruits, 5 training fruits which are nearer to testing fruit. Even in case k equal to 7 also you can consider. In that case we have to identify 7 training fruits which are nearer to a testing fruit, an unknown fruit. So here in this case, what I would like to identify, k is equal to 3. 3 fruits which are nearer to the test data point, the test fruit, which is 65 and 60. Instead of complex rules or boundaries, KNN simply ask which known fruits are most similar to this one. We will use k equal to 3, which means we will find the 3 nearest neighbors and let them vote on the classification basis. First of all, try to find the 3 closest training points, check their labels, and majority wins. Now the way how to calculate the distances, that is an important aspect. So measuring distances. So here we are using Euclidean distance. So the formula of Euclidean distance is equal to square root of sigma x2 minus x1 whole square plus y2 minus y1 whole square. The way how to calculate. The new point which is 65 and 60. The new point which is 65 and 60 can be x1, y1, and the rest of the points which are falling under apple category, banana category and orange category are the x2 and y2. So the way how to calculate, so the distance is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square, right? Suppose let me give suppose here let us check it out this whatever the total points are there, all the training points which has been given corresponding with features, sweetness of the fruit and weight of the fruit. You can see the training points, sweetness of the fruit and weight of the fruit, 75, 65, 76, 69, 74, 71, 78, 68, 70, 75. Likewise, for all the training data points, we are having corresponding coordinates like sweetness of the fruit and weight of the fruit. And from test data point, whichever, here you can see the test data point, which is 65 and 60, x1, y1. From this test data point 2, we have to calculate the distances towards the train data points. Here are the list of train data points, and this is the test data point. From these train data points, we have to calculate distances towards the test data point. That's the most important aspect here. So we have to calculate the distance from train data points to test data point. So already I given a calculation, square root of sigma x2 minus x1 whole square plus y2 minus y1 whole square. Now when we calculate this, so we will get the distance from test data point to train data point. We have to consider, as I already taken k equal to 3. That means I want to consider the first 3 shortest distances from test data point to train data points. So I arranged all these distances in an ascending order from shortest distance to the longest distances. From shortest distance to longest distances, arranged in an ascending order. So the first 3 distances can be considered as the shortest distances, as because I considered k equal to 3. That means that I would like to identify the first 3 nearest distances from training data points to testing data points, right? The way how to calculate square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now this particular formula will fall under Euclidean distance. Instead of this particular formula, you can use Manhattan distance also. You can use Chebyshev's distance also. We can use Minkowski distance also. Even Hamming distance also. But here I used Euclidean distance. I would like to measure the shortest distance from train data points to test data points. So after all calculation, all these distances kept in the ascending order from lowest value to lowest distance to highest distances. But as my k value is 3, I considered the first 3 distances. When I closely observe, these 3 fruits are belongs to apple. So therefore, the new test point, the new fruit, it is belongs to apple community. It is belongs to apple category. So the new test point, it is belongs to apple category. Similarly, that's what. Even once after distances calculation, we have to arrange all distances in an ascending order, least distances to highest distances. If I put those one in an ascending order, here the 3 least distances, k is equal to 3, 11.18, 14.21, 14.21. When I observe, these 3 fruits are belongs to apple. So therefore, the new data point or the new fruit, it is belongs to apple category. Now what if k equal to 1? What if k equal to 5? And what will happen if k equal to 7? When k equal to 1, it is a too sensitive, as because we are trying to identify only one closest training data point to testing data point. When k equal to 1, too sensitive to noise, one outlier can mislead the entire assessment. So we should not take k equal to 1. We have to take k value in between 3 to 7 for good balance for most problems. Large k means more suitable but may include irrelevant neighbors also. In that case, again we have to go for voting method. Voting method will tell us about what? Out of, suppose if k equal to 10, 7 fruits are belongs to apple and 3 fruits are belongs to banana stands for, and again majority voting, 7 fruits are apple and 3 fruits are banana. So therefore that new data point, it is belongs to apple category. This is what the concept of k nearest neighbor classifier.